In this video, I want to look at a couple of application problems where we have to use logarithms in order to solve. And these are a couple of problems from when we first were introduced to this over in section 4.1. But in this situation, we're going to be solving for t. And so solving for t, which is in my exponent, is going to require me to have to use some logarithms in order to solve this. So the problem says that suppose $3,000 is invested at 3% interest compounded monthly. It says how long will it take for that investment to triple? And we're going to have to solve algebraically using logarithms, and then we're going to have to use our calculator, whether you're using a graphing calculator or a scientific calculator, either one of them will do this for you, to be able to round our final answer to a couple of decimal places. All right, so they give us some values here, and we've got our compound interest formula. So it says suppose $3,000, so that's our principal, and is invested at 3% interest. So we'll have to take our percentage and convert that to a decimal. There's my interest rate. Compounded monthly. So that's going to tell me that my value for n is 12 since we're compounding it monthly. And it says how long is it going to take for this investment to triple? So I have my initial investment of $3,000 and I want to triple that amount. So if I want to triple that amount, I want to figure out when I have $9,000. So I'm going to figure out how long is it going to take me to get $9,000 if I invest $3,000 at 3% interest that is compounded monthly. So I'm going to plug everything into my formula here. So this says that 9,000 is going to be equal to 3,000 times 1 plus, and then we have 0.03, that's our percentage converted to a decimal, divided by 12. So we're dividing by that value of n, which is 12, and all that raised to the 12 times what I'm looking for, which is t. So now we're just going to have to go through, clean this up a little bit, and then go through and do some algebra in order to solve this. So we have that 9,000 is equal to 3,000 times, so come inside the parentheses there, you have 1 plus 0.03 divided by 12. So use your calculator, do 1 plus 0.03 divided by 12, and you're going to get 1.0025. Avoid rounding that in any way, shape, or form. You don't want to round until the very end of the problem. So since you don't want to round to the very end, leave everything exact. And all that raised to the 12 times t. All right, so now what I have is I have an exponential equation. So since I have an exponential equation, the first thing that I've got to do is I have got to get this expression right here by itself. I cannot multiply that 3,000 into that 1.0025 because I have to do exponents first. So I've got to take that 1.0025 and raise it to the 12t. And since I don't know what t is, I can't simplify that in any way, shape, or form. So I've got to get this expression right here isolated before I do anything else. And so in order to do that, I'm going to have to move that 3,000 over to the other side of my equation. And so to do that, I'm going to have to divide both sides by 3,000. And so if I divide both sides of that equation by 3,000, then what I get is that 3 equals 1.0025. All of that, I'm going to leave it in parentheses for a minute, all that raised to the 12t. All right, so I have that 3 equals 1.0025, that entire thing raised to the 12t. So now that I have this exponential by itself, next thing I'm going to have to do is I'm going to have to get this t out of my exponent. And so to get this t out of my exponent, I'm going to have to use logarithms. And since my base is not 10 and my base is not e, it doesn't matter whether I decide to use natural log or I decide to use just regular old log. Either one of them will be perfectly fine. I'm going to use natural log just because I generally use natural log for almost everything. Unless it's base 10, then I use log. So I'm going to take natural log of both sides. I'm going to have natural log of 3 is going to be equal to the natural log of 1.0025 raised to the 12t. Now what that does for me is applying the natural log to both sides allows me to get this 12t out of my exponent, because we have that property that says log base a of m to a power is the same thing as that power times log base a of m. That's one of my properties of logarithms that we discussed over in 4.3. So that says that the natural log of 3 is equal to 12t times the natural log of 1.0025. So my goal here is to solve everything for t. And so since my goal is to solve everything for t, I need to get t by itself. So what is happening to t? It's being multiplied by 12 and it's being multiplied by the natural log of 1.0025. So what I'm going to have to do is divide by all of that. So I'm going to divide by 12 times the natural log of 1.0025. That is all one thing, so I would keep all of that in some kind of grouping symbols. So I'm going to use brackets. And so over here, I'm going to divide by all of that. I'm going to divide by 12 times the natural log of 1.0025. And that will give me what t equals. And so I've got to put it in my calculator like I see it here. Now every calculator is different in terms of the mechanics of how that calculator works. But I'm going to use my graphing calculator, okay? And so I need it to do the natural log of 3, and then I need it to divide by all of this here. I need to divide it by 12 times the natural log of 1.0025. So however you want to do this in your calculator, but you've got to be careful about typing this in. So it's going to have to be the natural log of 3. Now on my calculator, when I hit ln, it opens a parentheses. So I've got to turn right around and close that parentheses. And then I want to divide it by everything. I want to divide it by 12 times the natural log of 1.0025. So I've got to have 12 times the natural log of 1.0025 all in parentheses. So 12 times, I don't have to put my time symbol in there from my calculator. On another type of calculator, you probably would. So 12 times the natural log of 1.0025. Okay, so I got to close my parentheses around the natural log, and then I want 12 ln of 1.0025 to all be grouped together. So you want your calculator to do that right there. So what your calculator is going to do is it's going to find what 12 ln of 1.0025 is, and then whatever that value is, it's going to do ln of 3 divided by that entire value. So be very, very careful if you're using a scientific calculator or another kind of calculator. You may have to do it in steps. You may have to figure out what natural log of 1.0025 is, then multiply that by 12, and then do ln of 3 divided by that whole thing. That's one of the advantages of a graphing calculator or a calculator like this, is you can use parentheses and different things. And there's different models of calculators that allow you to do that as well. So just be very, very careful about that. Okay, so when I hit enter, I get 36.6661, so on. Okay, so there's my decimal value. So back over here, it was asking me to round this to 2 decimal places. So rounding to 2 decimal places, t is going to be equal to 36.67, and in the context of my problem, the time is represented by years. So it would take you almost 37 years. Again, round accordingly. In this situation, it asked me to round to 2 decimal places, so I rounded to 2 decimal places. So it would take me 36.67, which is almost 37 years, for me to triple the amount of money that I had in that account. All right, so let's look at one more example. And just to talk through a couple of things. So it says, suppose that $3,000 is invested at 3%. So same kind of setup as before, compounded continuously. So read very carefully because you have just regular compound interest, which is a different formula. If they ask you about being compounded continuously, then you're going to have to switch to a different formula. And that formula is P times E raised to the RT. So A is the same as it was before, P is the same as it was before. It's just the 1 plus R over N is now replaced with that number E, for which you will have a button on your calculator for, and then that raised to the R times T. So it says, how much is in the account after 10 years? Well, that is just me plugging in everything that I have and figuring out a value. And so in that situation, this is going to be A is equal to 3,000 times E raised to the 0.03 times 10. And so that says that A is going to be equal to 3,000 times E raised to, then we have the 0.03 that we're going to be multiplying by 10, and so that's just going to turn into 0.3. 0.03 times 10 is going to leave you with 0.3. So on my calculator, I would have to do 3,000 times E raised to the 0.3. And so I would come over here on my calculator and I would do just what it says. So I do 3,000 times, hit my second, hit my button for E, raised to the 0.3. And you should have a button on your calculator somewhere that has an LN, and above that LN button is that button for that number E that was discussed over in 4.1, that 2.71828, kind of like pi. We have a symbol for pi, we have a symbol for E for the number 2.718, just like we have a number for 3.14. Same idea. And that would give us $4,049.58. So $40.49.58 if I rounded that to 2 decimal places. So this would be $4,049.58. Since we're talking about money, we'll round it to the nearest cent. Sorry about that. So $40.49.58. All right, so that's just plugging in into your formula, figuring out your value there. Part B is the part where we get back to our logarithms, because it says, how long will it take? So how long will it take means we're looking for t in our problem here, and that's up there in our exponent next to that r, so that means we're going to have to use our logarithms to solve. So how long is it going to take for that investment to grow to $20,000? So let me get a blank slide here. All right, so how long is it going to take to have $20,000? So I need 20,000 to be equal to 3,000 times e raised to our interest rate, which is 0.03, all that times t. So again, we're trying to get this t out of the exponents. So my very first step is that I have got to get this entire exponential expression by itself. So I'm going to have to divide both sides of this equation by 3,000. So if I divide both sides by 3,000, my zeros cancel, and I'm left with 20 over 3 is equal to e to the 0.03 times t. So now, since my base is e, we absolutely want to use natural log, because that's going to make this a very simpler problem to type into our calculator if we do that. If this were a base of 10, I'd use log. Since it's a base of e, I'm going to use ln. And so I'm going to have that the natural log of 20 over 3, leave that as an exact value, is equal to the natural log of e raised to the 0.03 times t. So just like my previous problem, this becomes natural log of 20 over 3 is equal to, I'm going to bring my exponent down, and this is going to be 0.03t times the natural log of e. So since my base is e, and since I used ln, this expression here is a nice value. The natural log of e is 1. So that just turns into 0.03t times 1. So this just becomes the natural log of 20 over 3 is equal to 0.03t because I'm multiplying by 1. So again, look for that. When you have e, if you use ln, then this portion right here will be a nice simple value as long as you use ln. If it were 10, I'd use log, and log of 10 would have been 1 as well. So we look for those two things when we can. All right, and then my last step here, follow me up over here. My last step here is I want to divide both sides by 0.03 because that 0.03 is multiplying t. So my final answer here is going to be the natural log of 20 over 3 divided by 0.03. That is going to equal t. Obviously, we want a value we can work with and wrap our head around, so we're going to have to use our calculator to get a decimal value for that. So I'm going to go back to my calculator, same kind of idea. I'm going to have the natural log of 20 over 3. Get rid of that stuff up there above it. So natural log of 20 divided by 3. All that needs to, the 20 over 3 needs to be in parentheses because you're taking the natural log of that. And we're just dividing by one thing, so we don't need multiple parentheses or anything. We just need to divide that by 0.03. So when I do that, I get t is equal to, and then again, we're going to round accordingly. So this is 63.237. And so we'll go back here and we'll round this appropriately. And it says round your final answer to 2 decimal places. So if I round that to 2 decimal places, it's going to be 63.24 years. And so my final answer here is going to be that t is equal to 63.24 years. So a little bit more than 63 years to take that $3,000 and grow it to $20,000. So again, if they ask you to solve for t, if they're asking you to solve for something up there in the exponent, you're going to have to use logarithms. There's no other way to do it. You're going to have to use logarithms to solve it algebraically. And I hope those 2 examples will help you with your algebraic steps that you have to use to solve that.